Hi guys, welcome to our third and final video. All right, so today, of course I've talked about determining the mass of the formula, and I've talked about finding the percent composition of a particular compound. But now I'm going to show you a couple variations on percent composition problems. So these are just going to be some other kind of percent composition problems that you're going to see. So I'm going to give you some examples of how to solve them. So hopefully you have the sample problem worksheet to go along and fill in, so you have that to refer to. So when I'm finished with this, you'll have your own percent composition worksheet 3 that you're supposed to be working on. So several of these problems will show up there. All right, so let's get started. Okay, so first of all, this is just the first normal one, percent composition. So this is what you guys would have done yesterday for homework, the examples that we would have covered yesterday. So if you want to find the percent composition of iron oxide, first thing we're going to do is we're going to have to figure out the mass of each of the mass for iron, the mass for oxygen, and then we're going to have to, find the mass of the compound. So that's what these examples are going to be. All right, I'm not going to dwell too much on this because, of course, you've done this before. You kind of know what you're doing there with that. So even if you don't have time to copy this down, it's not a big deal. I'm not really that concerned about this problem. It's the next couple problems that I really want us to look at. All right, so there we go. So we found the mass of iron, the mass of the whole compound, divide mass of iron by the mass of the compound times 100, giving us the percent. Mass of oxygen divided by the mass of the compound times 100, giving us the percent. Oops, sorry. If you were wanting to write that down, you can do that. I double clicked by mistake. Okay, now next problem. All right, now this is an example of a problem that actually has sig figs in it. So the other problems that we've been looking at, like I said yesterday or earlier today for fifth period here, these are problems that anytime you're pulling numbers off a chart, they don't have sig figs. Somebody who made the chart or made the periodic table decided where to cut them off, and that's how they came about having 2 decimal places or 1 or whatever it is. Okay, but whenever you see a number listed with an actual unit, that signifies we have a measurement, and measurements do have sig figs. So when we're multiplying and dividing with measurements, something that has a unit, like in this example, grams, then we do have to care about sig figs again, okay? So if we take a look at this number here, this number has 5 sig figs. If we take a look at this number here, this number has 4 sig figs. So when we were doing our math in this particular example, we would make sure our answers had 4 sig figs. Okay, so let's read this problem. It says, this is the mass of the whole compound. So they actually put this on a balance and found the mass of the whole compound. So here it is. And then it says a compound that contains phosphorus and oxygen. So we don't know its formula, but we don't really care for its formula. We just want to care about the different elements that we have. And it says here that the contains 82.96 grams of oxygen. So this is the mass of oxygen. Okay, so of course we want the mass of both oxygen and phosphorus. This is the mass of the compound that's made up of both oxygen and phosphorus. This is the mass of oxygen. So the first thing we're going to have to do is find the mass of phosphorus. Okay, so that's just a subtraction problem here. So there's the mass of our compound. There's the mass of oxygen. So we subtract and we find this is the mass of our phosphorus for this particular compound. Okay, so now we have the masses, the real actual masses of each of these things, phosphorus, oxygen, and the compound. Okay, so now we can do our percents. So we have phosphorus, the mass of phosphorus divided by the mass of the compound times 100. Okay, answer with 4 sig figs, just like the mass here had. This one had 5, this one had 4. We always go with the least, so our answer has 4 sig figs. Okay, oxygen's turn. Mass of oxygen, mass of the compound times 100. Answer with 4 sig figs. Okay, so there's our percent composition or percent of phosphorus and oxygen for this particular compound. Since it had actual measurements here, as listed in our problem, we have to make sure we're using sig figs. All right, next kind of problem that you'll see. I'm sorry, guys, you might have still been writing things down, so let me leave that for a couple minutes or a minute or whatever, so you can catch up. All right, if you need more time, ask somebody to pause because I'm going to keep going. All right, our third problem here is a percent composition problem again. But the only difference is instead of asking you for the percent of everything, okay, it's asking you for the percent of just one of our elements. So it says, what is the percent of sodium? So apparently we don't care about sulfur, we don't care about oxygen, we only care about sodium. Well, to start off, you have to do the problem the same way you would for a normal percent composition problem. You just won't have to continue until the very end. You'll get to stop partway through. Okay, so first step is always finding the mass of each element. Mass of the compound. Okay, once again, these are all coming from the periodic table. Again, these aren't actual gram amounts. These are, numbers from our periodic table. All right, so now at this point, if you were just doing a normal percent composition, you would then find the percent of sodium, then the percent of sulfur, then the percent of oxygen, but you don't have to do that. Instead, you just have to find the percent of sodium. All right. And so there's our percent of sodium. So we can stop the problem now. We don't have to continue any further to get sulfur and oxygen. For whatever reason, we only cared about sodium in this particular problem. Okay, I'll give you a little bit of time. Make sure you have it copied down. Now you can hear somebody whistling perhaps in my other room here. Got a lot of people in this house right now, so there could be interruptions at any moment. All right, next and final problem. Okay, so this is actually going to end up being a proportion problem. Okay, so if we read through, we see how many grams of aluminum would be present in a 125 gram sample of aluminum fluoride. So at this particular time, we do not know the answer to this, but we can get the answer if we can find out how many grams there would be in whatever the mass on the periodic table is. So in other words, we have to turn this into a proportion problem, one in which we're comparing the amount of aluminum in aluminum fluoride with information that comes from the periodic table, and then one where we're including the mass of aluminum and the mass of the compound, which comes from the problem itself. Okay, so let me show you what that would look like. All right, so we have aluminum, the mass of aluminum from the periodic table, so I'll look that up. The mass of the compound, aluminum fluoride from the periodic table, so I'll add that all up, okay? And then once I have that information, that comparison of aluminum to aluminum fluoride, then I can use that comparison to then answer the question, how much aluminum if I have this much aluminum fluoride? Okay, so it's going to end up being a proportion problem in which we're going to solve for x. Okay, so next step will be getting this information from the periodic table. Okay, so we look up the mass of aluminum on the periodic table. There's only one of them, so there we go. The mass of fluorine on the periodic table, there's 3 of them, so there we go. The mass of the whole compound then is 83.98 grams. So if I had 83.98 grams, then this would be an easy question. I already know the answer. 26.98 is how much aluminum there is. But as you can see in the problem, I don't have 83.98 grams. So now I'm going to have to do a proportion problem then to figure that out. So here's the mass of aluminum from the periodic table, the mass of the whole compound, which came from the periodic table, and I'm going to compare that to the mass of aluminum. That's the question mark that we had from the problem. How many grams of aluminum? Okay, so that's my x, what I'm going to be solving for. And the mass of the whole compound, of course, in the problem tells us 125.0. So we have x over 125.0. All right, so now at this point, I need to solve for x. So most of you guys have probably done this before in your time. And so you know to solve for x, probably the easiest way to do that is to cross multiply. All right, and then divide. So I think I don't have the in-between math, I just have the final answer. So that would be like x times 83.98 equals 26.98 times 125.0. And then when everything's said and done, my answer should once again be in sig figs because 125.0 grams is a sig fig number. It's a measurement. And so therefore it has sig figs. It happens to have 4. So when I get finish, my answer then is going to have 4 sig figs like this one does. All right, so we find the mass of aluminum from the periodic table, mass of the compound from the periodic table, and we compare that to the mass of aluminum, which is what we're looking for, X, over the mass of the compound, which comes from the problem. We cross multiply to solve for X. Okay, so those are the 3 kinds of problems that you will come across when you go to do worksheet percent composition worksheet 3, which of course will be your next task here today. So to work on that worksheet and finish it up. And of course, I should be back with you then the next time we have class together. So, all right, guys, have a good one, and I will see you soon.